In this tutorial on industrial instrumentation, we will talk about flow measurement part 9. The discourse contents are metering pump, under which we will see reciprocating pump, peristaltic piston and diaphragm pump. The second type of quantity flow meter is the metering pump. A very common method for directly controlling low flow rates of fluids is to use a device which is known as a metering pump. A metering pump is a pump mechanism with a motor and drives electronics contained in a monolithic package. A simple 120-volt AC power supply and a control signal can operate a metering pump. Metering pump allows precise volume of fluids to pass through it in a very specific time scale. A metering pump is a positive displacement pump which is used to provide a predictable and accurate rate of process fluid flow. Only those pumps which have very little internal or external leakage are used for as metering pumps. Any positive displacement pump may be used as a metering pump due to its volumetric mode of fluid transfer. The metering is the name given to the precisely delivered adjustable flow rate. The term metering pump is based on the application and usage. Most metering pumps comprise a motor and a pump head. The motor pumps the liquid through the pump head into an inlet-outlet system with precisely known volume of the chamber. The metering pumps are mostly used for constant, mildly fluctuating flow rates. There are three types of metering pumps, which are reciprocating pump, peristaltic pump and diaphragm pump. The reciprocating pump is a positive displacement metering pump which uses a plunger or piston to change a cavity's volume and produces a differential pressure. A plunger pump operates using the reciprocating motion of plungers or pistons, and based on the design and usage, the plunger number can be single or multiple. It employs a piston or a plunger with inlet and outlet check valves, and the piston moves in a reciprocating motion in the chamber. Check valves prevent any backflow. It is mainly used in heavy chemicals and manufacturing. A backward movement of the piston allows liquid to enter into the cylinder, and forward movement causes discharge as shown here. In the suction stroke, the plunger retracts and suction valves open, causing suction of fluid to enter into the cylinder. Plunger in the forward stroke pushes the liquid out of the discharge valve. The salient advantages of the reciprocating pump are they can cater under high pressure and very low flow applications. The pressure can go as high as 10,000 psig. They are highly durable in very abrasive and corrosive applications, and the efficiency is well above 90%. The limitations are, however, they are high maintenance devices, they have short life, and generation of pressure pulses affect the response. The peristaltic pump is a type of positive displacement pump used for pumping a variety of fluids. The fluid is contained within a flexible tube fitted inside a circular pump casing. There are also linear peristaltic pumps available. A rotor with a number of rollers, shoes, wipers or lobes attached to the external circumference of the rotor compresses the flexible tube. As the rotor turns, the part of the tube under compression is pinched closed or occludes, thus forcing the fluid to be pumped to move through the tube. Additionally, as the tube opens to its natural state after the passing of the cam, that is restitution or resilience, fluid flow is induced into the pump. This process is called peristalsis. The body of fluid is then transported at ambient pressure towards the pump outlet. Peristaltic pumps may run continuously, or they may be indexed through partial revolutions to deliver smaller amounts of fluid. There are two or more rollers or wipers occluding the tube, trapping between them a body of fluid. The diaphragm pump, also known as the membrane pump or air-operated double diaphragm pump (AODD) or pneumatic diaphragm pump, is a positive displacement pump that uses a combination of reciprocating action of a rubber, thermoplastic or Teflon diaphragm and suitable valves on either side of the diaphragm to pump a fluid. The valve used can be check valve, butterfly valve, flap valve, or any other form of shut-off valves. When the volume of a chamber of either type of pump is increased, the pressure decreases, the diaphragm moves up, and the fluid is drawn into the chamber. On the next cycle, the chamber pressure increases with decrease in volume and the diaphragm moves down, and the fluid previously drawn in is forced out. Finally, the diaphragm is again moved up and draws fluid inside the chamber, thus completing the cycle. The main advantage of the diaphragm pump is that there is no possibility of any leakage unless the diaphragm itself gets damaged. The capacity of a pump is directly proportional to the diaphragm diameter, stroke, and the rate of reciprocation. For more detailed reading, the viewers can refer to the following links and references. Thank you.